In this lesson, we'll learn about Redshift Environment. This shader or object or atmospheric effect allows you to simulate light scattered by atmosphere or volume scattering and also fog. You can use this effect with almost all the light types, including area lights, spot and IES, infinite, sun and sky, and so on. We are in the classroom scene, and if I start IPR, we have the beginning of a moody, weird lighting for the scene. An orangish infinite light shines through the windows, and we also have used greenish mesh lights for these 6 ceiling lamps. For now, I'm just gonna turn off all the green lights and only work with the infinite light. To add a Redshift environment, go to the Redshift menu, Object submenu, and here you'll find it. Add one to the scene. You notice nothing happened and we cannot see any atmospheric effect in the scene, even though the Redshift environment has a scattering amount bigger than 0. That's because if you select the infinite light and go to the details tab, you realize the light's volume scale contribution is set to 0. If we start increasing it bit by bit, we start to see the volumetric scattering effect. For now, let's set it to around 0.15, and now we start to see this beautiful volumetric scattering in the scene. Let's get back to our Redshift environment to see its options. The first one we have is this color tint. We can control the color of the volumetric scattering here. If I select the infinite light, you notice it has a very low Kelvin temperature value of 1400s defined as its color, and that's why the volumetric scattering appears to be orange. If I set the color of the infinite light to a neutral white color, the volumetric scattering will look more normal and neutral as well. Now we can get back to the Redshift environment and try a few colors here. Let's stick with the default white color for now. Then we have this scattering amount, which controls the atmospheric volume overall density, or how strong the volumetric lighting effect is. We can start increasing and decreasing it to get stronger or weaker volumetric scattering effect globally for all the lights. But you can still control the individual contribution of each light to the atmospheric effects using the volume scale amount under the details tab for the lights. For now, let's change the color tint to a pure red and set the scattering amount to 0.5. Next, we have attenuation parameters. As I increase attenuation, the light will only travel through the volume for a short distance. And as I decrease it, the light travels longer distances. If I set the attenuation to something like 0.5, the light can barely travel through the volume. Let's try 0.25. Now the light can travel further through the volume. 0.1, even more. And finally, at 0, the light can go through the entire volume without being attenuated. Now, attenuation is more meant for non-infinite lights, so all the lights except for dome, infinite light, and physical sun. So let's take a look at the second scene where we have a Redshift environment already in the scene and a small area light with its volume contribution scale already bigger than 0. Let's start IPR here and get back to attenuation and take a look at its effect again, as it would be more obvious here. Because in the other scene, we're actually just increasing the fog amount. So let's take a look at it here and see how it works. So at something like 0.6, 0.5, you can see the light can barely travel through. At lower values like 0.3 or 0.2, it can go farther, and at 0 the light rays can go all the way through. Attenuation also controls the strength of the fog in the scene. We'll get back to that later on. For now, let's quickly see what this phase amount does. And to see this better, let's move around so we are looking directly at the light source. If phase amount is set to 0, the light will be scattered evenly in all directions. If I use positive values, more rays will be scattered in the direction that the light is facing. And as I go to the negative values, more rays will be scattered in the opposite direction. For now, set it to 0 and let's get back to our previous scene so we can finish the lighting there. I'm going to select the environment again, change its color tint to this orangish red, scattering to 0.1 and attenuation to 0.02. Select the infinite light, change its volume contribution to 0.6 and color temperature to 1400s. Turn on all the ceiling lamps and make sure their contribution scale is set to 0.1. We can try different scales here to see how they affect the scene. But 0.1 would be nice for now. Let's stop IPR and take a final render in the render view to see what we have. And here is our gorgeous render, which only took about 40 seconds or 35 seconds. We can use a curve to add a bit more contrast. And here it is, our final render. Let's open up our third scene for this lesson and learn how to add some fog to our renders in Redshift. Now start IPR. Here we have a simple Redshift sun and sky. Let's add a Redshift environment. And now we get this very strong volumetric scattering in the scene. We can start decreasing the scattering amount to get something more reasonable. Maybe something around 0.03. Now to add some fog to the scene, we need to start increasing the attenuation amount. As I mentioned earlier, this value also controls the strength of the fog. Let's try 0.1, 0.2, 0.3, maybe 0.5. Now we can start to get a sense of fogginess, but it's just black. To control the color of the fog, we can simply change the fog emission color from black to any other color. Let's try a very light gray for now. Now we can simply use the attenuation value to balance between volumetric scattering and fog. Lower attenuation values make the volumetric scattering more visible, and higher attenuation values make the fog effect more visible. For now, let's set the attenuation to around 0.2. Now we can take a look at these fog parameters. Height controls where the fog effect happens. At 0, it's everywhere. If I set the value to something like 10, now the fog is present only within 10 units on the y-axis. Let's try 20, 40, and maybe 50. Now, how can you control the direction of the fog? Right now you saw as we changed the height value, the fog was happening from the ground up based on the y direction. So let's say I want the fog to start from where these lovely people are. I can simply rotate the axis gizmo so the y-axis looks towards the camera. And now I can simply move the Redshift environment on y-axis and control the origin of the fog. But within Redshift environment, there are options that can do the same thing. If I just reset the transformation we performed and get back to the default orientation, we can turn off this use transform and instead use this ground point and normal to control the starting point and the direction of the fog. Ground normal defines the direction of the fog. Right now, the fog is on positive y. We can simply change the ground normal to, let's say, negative x. Or we can try negative z, and now the fog is on the z-axis, and we can move its starting point using this ground point. So ground point controls the starting point for the fog along the axis set by the ground normal direction. Right now the fog is on negative z direction, and for example, if I set the ground point on z to 30 units, the starting point moves 30 units along the z direction. And if I set it to negative, let's say 40, it moves the other way. We normally want a distance-based fog away from the camera, so let's change the direction to negative x and use the ground point x to control the starting point. Maybe around negative 650 for now. And horizon blur controls how much the fog affects the background. If set to 0, we can start to see our sun and sky shader, which is not quite desirable. We can start increasing the horizon blur to make the background shader fade into the fog. And finally, we have some self-explanatory ray contribution scale values. For example, if the GI contribution scale is set to 0, Redshift environment won't contribute to the global illumination, and at 1 it will. Or if reflection contribution scale is set to 1, Redshift environment will be visible on reflective surfaces, otherwise it won't. Maybe we can change the fog emission color to an eerie green color. That's cool. And if we wanted to combine the volumetric scattering and fog, we can increase the scattering amount maybe to something like 0.5, 0.4, and decrease the attenuation to maybe something like 0.1. Now we get both of them. And finally set the scattering color to something close to the fog color, maybe the same color as the fog emission, but with a bit bluer hue. And here it is. So that is about Redshift environment, volumetric scattering, and fog. See you in the next video.